Here we are at 5:30 in the morning with what has to be one of my favorite combinations in a JK. This is an LS3 Gen 4 engine with a 6L80 transmission. Sometimes more is not better. I believe the LS3 is the pinnacle of the small block Chevy. No air-fuel management, no variable valve timing, just a simple overhead valve engine that GM has been building since the 1950s. We are running our CAN interface in this Jeep. This is a 2011, very clean. I want to say something about data. Anybody who has a JK should really have the ability to scan their computer. And it doesn't matter if you've got a stock JK or a V8, a Hemi. Get something so that you can look at data and what's going on with engine performance. Most of you carry tools on the trail, whether it's an air compressor to fill your tires up or tools to change a tire. So you need the same tools to look at your engine performance. If you don't want to get a specific gauge like an Aeroforce Interceptor or a scan gauge, get one of these. This happens to be Torque. Torque is an app you can download on your Android phone, and they have similar Apple applications. You can purchase a Bluetooth adapter that plugs into your data link connector for under $10, and then you get to look into your engine performance system. With this application here, you can get codes, cleared codes, look at maybe 100 generic parameters, coolant temp, vehicle speed. Always have information. If you're in the middle of nowhere and you have a check engine light come on, you need to know what that is. I use Torque and other apps when I do my test drives because I'm looking at long-term fuel trims, of course coolant temps, tranny temps, and all that. For me, the LS3 is perfect in a JK. It's lightweight, compact, all aluminum. It does require premium fuel, and it does cost more. But other than that, it just runs perfect in a JK. The power delivery, the weight, the size, just match the JK perfect. And if you were going to drive across the country, you could put an LS3 in your JK and comfortably cruise at 75 to 80 miles an hour all the way across the country, even with larger tires like 40. The LS3, being as simple as it is a very rugged engine. I get a lot of requests to build the 480 and 525 horse based LS3 engines, and here's my opinion on that. I like the 430 horse LS3 engine. We're dynoing them at about 450 horsepower at the crank, and you should be in the high 3s, 395, 385 at the rear wheels based on your powertrain and tire size. Now if you've got an Atlas 4, 40-inch tires on beadlocks, you're going to be losing some power in the drivetrain. Overall, you should be pushing close to 400 horsepower at the rear wheels with a stock 430 horse LS3. The engine is as mild as can be. I am cruising along right now at 65 miles an hour. We are running our easy hydraulic motor mounts and our factory OE harness. All the easy technology is in this build. The LS3 430 was put into a production vehicle, obviously the Corvette and the Camaro, so we're running a production tune. This not only makes it compliant, but it gives you the drivability that the OE manufacturer put in. Now if we go to the 480 horse engine, they've got some different valve springs and different camshaft, of course, but there is no free lunch. So to get that top end power, you're going to sacrifice bottom end. You may not idle at 600 RPM, you may have a little bit of a rump, you may smell some hydrocarbons. That's the compromise for getting that top end power. You go to the 525 horse, I find that it's similar. Automatic transmissions don't like big cams in general. You're going to have to run a looser converter, so when you come to a stop, you're not pushing on the brakes all the time. When you're crawling, you want to make sure that you have the appropriate tune, because the higher horse engines can hunt. If you suddenly decelerate, that idle can drop off and you might even stall the engine. There's definitely some downsides with the higher horse engines. Now properly done, they run great. On the highway they're awesome, and on trails they're awesome. Personally, I don't think they make good technical motors, meaning if you're going to go crawl at Fordyce or Rubicon, I'd much rather have an LS3. In fact, you could run a 5.3 off-road and be happy with it. The great thing about the LS3 is it's a production engine, it has perfect factory OE drivability, and it's still well over 400 horsepower. It's just an amazing engine. And then when you combine that with a 6L80 transmission, you end up having a 4-to-1 low, a 0.6 overdrive. You get great off-the-line performance combined with low RPM cruising. We are right now at 65 miles an hour at 1850 RPM. While the Gen 5 engines are great, in an early JK they're just not necessary. You are going to spend a little bit more money. They're not as simple of an engine. They're not as well supported. This engine is probably better supported than any other in the world right now. You can go to pretty much any country and find LS3s in hot rods, in classic cars, etc. This is the universal swap engine of today, just like the small block Chevy was the universal swap engine of 20, 30 years ago. And I've been doing engine swaps a long time, going on 30 years. And I can say that when you compare what I was doing back in the 1980s to today, it's a completely different world. We used to put small block Chevys in Vegas, Toyotas, Broncos, you name it. We were pushing 200, 250 horsepower, 350 roller camshaft, intake manifold with a Holly carb or a Carter. They were putting out 250 to 350 horsepower, I'm going to say. Nothing like today. We're pushing 400 and something horsepower. I remember in the 80s and 90s when we switched over to fuel injection, it was huge because I used to wheel with the old carburetors, and a lot of times you just had to floor it going up some of these hills, especially when you had a center pivot float like some of the Hollys had versus a side pivot float. Rochesters were always pretty good on inclination. Carbureted vehicles had some restrictions on off-roading. Bouncing around too much, you can get float bounce. We used to put spring-loaded needle and seats in. When we went to fuel injection, and it wasn't even the port injection, it was the throttle bodies, it was huge. You could go down the steepest hills or climb the steepest hills with no issues. Starting them up in the morning was a lot better than the carburetors with their choke systems. The advancement in fuel injection in the 80s and 90s, in my opinion, really changed engine performance in production vehicles and in engine swap. Today I look at what we have. If you look at even a 5.3, we're well over 300 horsepower with drivability that we could only dream of in the old days. We can take these vehicles off-road, the roughest roads. We can go off camber, we can climb the steepest hills, and these injection systems just hold up. It's usually the fuel system that gives out before the engine performance system does. So we're really spoiled today with what we have available to us. If you look at the technology, even in a Gen 3 LS engine, with the lightweight construction architecture, cross-bolted mains, direct port fuel injection that's sequential, relatively high compression, meaning if you look at the engines from the 70s and 80s, we were 7, 8, 9 to 1 at the most. Now we're pushing 9, 10 to 1, 11 to 1 because of the combustion chamber technology we have. We've pretty much done away with the EGR valve, the exhaust gas recirculation valve. We've pretty much done away with secondary air systems. That's air that's injected after primary air, so it's injected into the exhaust or into the converter, aspirated converters. We've done away with all that complexity, and what we've ended up with is an engine that's extremely efficient in the mid to high 90%. What I mean by that is an internal combustion engine that's been throttled has a certain level of combustion efficiency. You're never going to get 100%. Now, if you put a Ram stack intake on it and you're at high RPM, yeah, your volumetric efficiency can exceed 100%. But for our production vehicles with the intakes that we're running and such, we're running in the mid 90s on efficiency, and that's pretty darn good. A lot better than we were doing way back in the day. And these motors are running so clean, you could run one of these motors in your garage and it would probably clean the air. Not that you're going to want to do that because of carbon monoxide, but they're just really clean running engines. So when you look where we've come, this LS3 is really the pinnacle of American overhead valve engine technology that we've used since the 1940s and 50s. I would say that the small block Ford and the small block Chevys of the 1950s really were the inception. Yes, they had V8s before that, but when Ford and GM pioneered the core casting technologies to reduce the core count so that we could build these motors in high quantity at an affordable price, it meant that we could throw these V8s in a wide variety of vehicles at a low cost. The LS3 is the ultimate refinement of that engine. Once we go into the Gen 5s, we're starting to get outside of the box. We're starting to get direct injection and a lot of camshaft technology. Really, if you look at what the LS engines have done around the world in the last 10 years, it's pretty amazing when you look at the Corvette running at Nuremberg or the European circuits with really 50-year-old overhead valve design technology. It's not a hemispherical combustion chamber like the Dodge engines. This is an overhead valve engine, and it's out there running with the dual overhead cam 4-valve engines of the European manufacturers, and they're holding together. You could take a ZR1 Corvette, a Z06 Corvette, and this is a very rugged engine. This is an engine that's going to be putting out a lot of horsepower for a long time. So that's what this LS3 represents. It really represents the best of American ingenuity and technology, refined to a point that it can compete with the best of the modern engines. Getting back to monitoring, we do run factory modules, harnesses, calibrations, and what this means is you can use factory diagnostics and tools. So what I'm looking at here right now is long-term fuel trims. And long-term fuel trims are really the culmination of everything that's going on inside your engine and transmission. We want to see the long-term fuel trims stay pretty close to zero. They're never going to stay they're not going to stay at zero all the time because of environmental conditions. I'm going to be going from just over 2,000 feet to over 8,000 feet on that mountain. So the barometric pressure is going to change. We're probably going to drop 25 to 30 degrees in temperature, and that's one of the reasons I do this, is you want to take the operating system and put it in different environments. If you were to take, let's say, a stock JK that has speed density operating system, what that means is there is no actual airflow meter, mass airflow sensor. They basically use calculated airflow based on intake manifold vacuum, engine RPM, and some other parameters. And when you calculate airflow, you're pretty much guessing. And you don't have a barometric pressure reading. Usually when you key up, it takes a barometric pressure reading off of the map sensor, and that gives you a baseline. And then using calculated airflow, you can guess at what the actual airflow is for your fuel and spark delivery. The LS does have an actual airflow meter, and the Gen 5 motors actually have a humidity meter built in. So they're more accurate on the density and the quantity of the airflow going into your engine. In the older days, and even with the JKs with V6s and speed density, if you were to go, let's say, from 2,000 feet to 8,000 or 10,000 feet on a single ignition cycle, your baro would be way off, and you might have to stop and key down and power back up to get a new baro reading for your engine to run right. Seeing a lot of these engines run goofy when they get up to altitude, when they've started the trip off at low altitude. The LS engine does have a airflow meter, so it does use actual airflow in its calculations. And basically what these long-term fuel trims are telling you is the airflow meter is agreeing with the rest of the operating system. So the intake manifold vacuum, engine RPM, and temperatures are all in agreement, and they're monitoring each other. The map sensor actually monitors airflow by, it knows what airflow should be under certain conditions, and if that airflow gets out of line, you end up throwing a MAF irrationality or airflow irrationality code. We've already climbed a couple of thousand feet since we got off the highway. What that means is our barometric pressure has dropped, and the operating system has to calculate for that. And you can see that our long-term fuel trims are staying pretty darn steady. So that means that this operating system is running very efficiently. If you were to see these trims go 10%, 15%, 20%, plus or minus, plus means the operating system is adding fuel from what the base is, and minus means it's pulling fuel away. But if you were to go plus or minus 15 or 20, there might be something wrong in the operating system, the tune. You might have a slight air leak. If you start hitting 25, 30%, you're going to reach what's called the maximum adaptive limit. That's as much as the computer can compensate. You're going to start throwing codes like lean codes or rich codes, and then you have to identify what the issue is. It could be a host of issues: bad O2 sensor, air leak, low fuel pressure, or just a bad calibration.